You know, every single time you log into your computer or you shoot off an email or even just open up a command prompt, you're basically shaking hands with ghosts from the past. Today, we're going to pull back the curtain on this almost forgotten system from the 1960s that, just by trying to solve one really big problem, ended up accidentally inventing so much of the digital world we all live in. Let's trace the code all the way back to its source. It's a pretty fair question, right? I mean, we take multitasking completely for granted. But back in the early days of computing, the reality was, well, it was a whole different universe. A world with these incredibly powerful machines, but also a world of incredible frustration. So to really understand the revolution that happened, we've got to first understand the old way of doing things. So welcome to the era of batch processing. The name itself just sounds slow, doesn't it? And for good reason. It absolutely was. This was the main way people worked with those giant mainframe computers back in the 50s and early 60s. Yeah, so the slide gives you the definition, but to really get it, you have to put yourself in a programmer's shoes. Imagine you write some code, but you've got one tiny bug in it. You would have to punch your program onto cards, hand that stack of cards to an operator, and then come back the next day just to find out it failed. Then you'd fix that one little error and do the whole process all over again. I mean, debugging a program could take weeks. There was zero interactivity. It was this slow, painful conversation with the machine. But a few really brilliant minds realized this was just an incredible waste of time for both the humans and the machines. The computer itself was just sitting there, idle, most of the time, waiting for slow stuff like card readers. So they started thinking, what if? What if it could do more than one thing at once? What if it could share its time? This leap in thinking is honestly best understood with an analogy. Think of it like a chess master. Batch processing is like that master playing one opponent, finishing the entire game and only then moving to the next person in line. But time sharing, that's like the same master playing 20 opponents all at the same time, zipping from board to board so quickly that every single player feels like they have the master's complete, undivided attention. That right there, that's the conceptual leap that changed absolutely everything. And, you know, this idea didn't just pop up out of nowhere. As early as 1954, visionaries like John Backus were talking about this exact concept. The hardware just wasn't quite there yet. But the dream of turning one massive, expensive machine into a bunch of small, interactive ones, that was already taking shape. And the place where this dream finally became a reality, that was MIT. Researchers there developed what would become the very first general-purpose time-sharing system. They called it the Compatible Time-Sharing System, or CTSS, and that compatible part was pretty clever. It meant it could still run all those old batch jobs in the background, which made the transition way easier for everyone. And development happened fast. I mean, really fast. The theory gets solidified in '59. A first demo is up and working by '61, and by 1963, it's a daily use system at MIT. This was brand new. For the very first time, dozens of users could be logged in and working on the exact same computer at the exact same time, all from their own terminals. And the hardware they did this on, well, it really puts the whole achievement into perspective. They did all of this on a modified IBM 7094. Just look at that memory spec. 2 banks of 32,000 words. We're talking about kilobytes of memory here, not gigabytes or terabytes. It's just a stunning testament to the sheer ingenuity of the software that they built. This whole collaborative, multi-user world on hardware that's less powerful than a calculator you'd buy today. But here's the kicker. CTSS didn't just solve the efficiency problem. In solving that one big problem, it forced its creators to invent solutions for a whole bunch of brand new challenges. And those solutions are now just fundamental parts of our daily digital lives. Okay, so think about it. If you have a whole bunch of users on one machine, how do you keep their files separate and secure? Well, you give each user an identity and a secret word to prove it's them. CTSS was the very first system to implement password-protected logins, creating a concept so fundamental we literally can't imagine a world without it now. And with all these users logged in at the same time, it became pretty obvious they needed a way to communicate with each other. So the CTSS team created a simple messaging command. A user could send a message to another user's mailbox that they could read the next time they logged in. Just like that, they'd invented electronic mail. Oh, and this next one, this is a classic programmer story. There was a programmer named Louis Pouzin who just got tired of typing the same long sequence of commands over and over and over again, so he created a command called runcom, short for run commands, that would execute a whole list of commands from a single file. That is the direct ancestor of every single shell script, batch file, and workflow automation we all use today. And the list, it just goes on and on. They created a tool called Runoff to format text documents. That's basically the great-grandparent of things like Markdown. They built shared directories, which is the foundation for network drives and services like Dropbox or Google Drive. They even had a kind of instant messaging and hosted ELIZA, one of the first ever chatbots. All of this was happening in the mid-1960s. It's incredible. So CTSS was clearly a total game changer. But its most important legacy isn't just the individual features it invented, but the systems it directly inspired. Its DNA didn't just survive, it multiplied and spread everywhere. Just look at this lineage. You can draw a straight line. The team behind CTSS went on to create its successor, a much, much more ambitious system called Multics. But when that project got a little too big and complex, a few researchers who had worked on it decided to build a simpler, more elegant version for a smaller machine. And they called it Unix. And hey, don't just take my word for it. This quote is from Dennis Ritchie, one of the creators of Unix and the C programming language. He saw Unix as a direct descendant, a modern take on the core concepts that were first proven by CTSS more than a decade earlier. I mean, just think about that. The line from that one MIT mainframe to the Linux servers that run the internet, to Mac OS, and even to the Android phone in your pocket is direct and completely unbroken. So ultimately, this is the main takeaway. CSSS isn't just some dusty historical footnote. It's the grandparent of it all. The ideas that pioneered interactive sessions, file security, electronic communication, managing different processes, they literally became the blueprint for the operating systems that would come to define our entire modern world. So it kind of leaves us with this fascinating thought to chew on. CTSS flipped the whole computing paradigm from one computer for one job to one computer for many people. But today, with our laptops and our phones and our watches, we live in a world of many computers for one person. So as we look at today's cutting-edge tech, things like distributed computing or AI agents or quantum processing, what's the next big paradigm shift? What's the thing that future generations are going to look back on as their own CTS moment? It's something to think about.